Grade 5 pupils looking at our double angle formula. And previously we've had trig identities within National 5 for tan x and side squared x plus cos squared x. And now we're in introduction of our double angle formula. For sine 2a, just 2 sine a cos a, and cos 2a, where we have 3 different formula. Okay, and these can be interchanged at times or specific ones to be used. So just to look at some example proofs, just to show that these formulas all are true. So sine 60, we know that sine 60 is one of our exact values, which is root 3 over 2. So if we use our sine 60 and consider this as sine 2a, we would be considering this as sine 2 lots of 30. With a value 30, we have 2 sine 30 cos 30, which is 2 lots of a half times by root 3 over 2. Multiply numerators gives me 2 root 3. Denominator is 2 times 2 is 4, which simplifies to root 3 over 2. So that is correct to compare it with sine 60. Okay, next up, cos 60. Cos 60 we know is a half. That's one of our exact values. So again, for each of these, if we're just going to consider this as cos 2a, we would consider this as cos 2 lots of 30. And that's equal to cos squared 30, subtract sine squared 30. Rewrite that, which is cos 30 squared, a wee bit easier to calculate in that format. Cos 30 is root 3 over 2 squared, a half squared, root 3 times root 3 is 3, lots of 4, 1 squared, 4, which is equal to a half, which is what we expected. Again, let's consider as cos of 2 lots of 30. So 2 lots of cos squared 30 minus 1, which is 2 lots of cos 30 squared minus 1, which is 2 lots of root 3 over 2 squared minus 1, 2 lots of 3 over 4 minus 1, 6 over 4, 1 is 4 lots of 4, which is 2 over 4, which is, as expected, a half. And finally, cos of 2 lots of 30 is our cos 2a. 1 minus 2 lots of sine squared 30. 1 minus 2 sine 30 squared. 1 minus 2 lots of a half squared. 2 lots of a quarter. 1 minus 2 over 4. 1 minus a half, which is again a half. As expected, so that is some examples of our double angle formula.